All right, we're working on 220B, which is 37 to 55 odd. And all these problems are the same. So the instructions say the function f is 1-to-1. What does it mean to be 1-to-1? Every x hits only one y, and every y is only hit by one x. So there are just as many x's as there are y's. Find its inverse and check your answer. And then state the domain and the range of both f and f inverse. So I would like to do number 42. So if f of x is equal to the square root of 3 minus x, how do I find its inverse? Switch, so this is y equals, switch the x's and y's. X equals the square root of 3 minus y. Now I need to solve for y. How do I solve? Square both sides. So this cancels that. We get x squared equals 3 minus y. So I'm going to subtract 3 and then multiply by -1. So y equals 3 minus x squared. How do I verify that that is in fact the inverse? Plug either one into the other one. It doesn't matter which order you do it in. So if I stick this in here, I get the square root of 3 minus 3 minus x squared. So 3 minus 3 cancels, and if I distribute that negative, I get the square root of x squared, which equals x. And that is the identity function. And if you compose two functions and you get the identity, those two functions must have been inverses. So now we state the domain and range of each. So what is the domain of the original? What numbers can you not plug in? Anything lower than 3. Is 3 okay? 3 minus 3 is 0, and the square root of 0 is 0. So the domain of the first would be 3 to infinity. Does 3 count? Yes. And infinity does not. Okay, and now this is a little bit tricky. What is the domain of that? You can plug any number you want in there. So we kind of have a little bit of a problem. The original graph looks like 3 minus x. Oh, I got that wrong. So square root of 3 minus x. Can you plug in 4? No, 4 doesn't work. So it's actually negative infinity to 3. So the graph looks like this. But the inverse, 3 minus x squared, looks like this. Is that what it was? Was it 3 minus x squared? Okay, do those look like inverses? So are they inverses? We just proved that they were, but only half of this graph is actually, and I don't think I drew it very well, so it should be actually like this. So if you draw that line, this piece and this piece are inverses, so that is actually not part of the inverse, because the original function had a restricted domain, and the new function had an unrestricted domain, and sometimes this book does weird things, so let's see how they want us to deal with it. So if you look at 41, let's go to the answers. So this is set 1.5. So set 1.5, look at the answer for 41. Oh, you can't see that. So for 41, the original function is the square root of, is it x minus 3? X minus 3. So what is the domain of that piece? Well, we can plug in 3 and anything bigger. So there's the domain. Okay. But the domain of this is the range of the original function. If you look at this function, you can plug anything you want in there, right? So if I were to draw, this is function f, I can put in 3 and 4 and 5 and 6 and everything on from there. And that function is 1 to 1. If you look at f inverse, any number can go in that, right? But that function was created by taking this and switching it around. So because 2 did not attach to a number, whatever number it would have attached to cannot be part of the domain of the new function. So what you need to do is figure out, well, what does 3 attach itself to in the original? Well, if I put 3 in there, I get 0. And if I put 4 in, I get the square root of 1, which is 1. If I put 5 in, I get 5 minus 3, which is the square root of 2. And then the square root of 3. And then the square root of 4, which is 2. And the square root of 5. What do you notice about this list? It's everything from 0 and bigger. So even if the new function has an unrestricted domain, the actual domain is only listed in the range of the original function. Does that make sense? Do you want to see another one of those? Okay. So 220. Okay, so let's do 38. So x equals 2y minus plus 3. Subtract 3, divide by 2. X minus 3 over 2. So now I need to verify. I'm going to stick this back in there. 2 times x minus 3 over 2 plus 3. The 2's cancel and the 3's cancel, and I'm left with x. So they are inverses. What is the domain of the original? All real numbers. Okay, if you graph that, it's a straight line that looks like this. All x values show up. What is the range of the original? All real numbers, because all of the y's show up. So when I do the reflection, the new domain of this line right here is all real numbers because the original range was all real numbers. So that one ended up being really easy. Look at 40. The graph of 40 looks like this. What is the domain of the original? All real numbers. So when I invert it, x equals y to the third minus 1. I'm going to add 1, x plus 1, and then cubed root. Does the cubed root have a restriction on its domain? No. So the range of the original was all real numbers. The range of the domain of the inverse is also all real numbers. Okay? It's the square roots that are going to give you problems. So let's do let's do 46. So x equals y minus 3 squared plus 2. What is the domain of this? Are there any numbers you cannot, well, sorry, the original. What is the domain of x minus 3 squared minus 2? All real numbers. Okay, but is this one-to-one? No. Why not? It's a parabola. Does a parabola pass the horizontal line test? No. So they have restricted the domain. If you graph that, you're going to go right 3 and down 2, and then you have a parabola that looks like this. But they said the only parts of the graph that counts is anything x is greater than 3. So they have thrown out all of this. So now what is the domain? From 3 to infinity. Now I invert. So x minus 2, I take the square root, and I get plus or minus the square root of x minus 2, and then plus 3. Am I doing both the plus version and the minus version? Well, let's look. So I'm going to go right 2 and up 3. So right 2 and up 1, 2, 3. The plus version would look like that, and the minus version would look like that. Which one is a mirror image of the original? So here's the reflection line. Oops, I didn't draw that right. The reflection line would be right here. So this is the inverse of that. So it's only the plus version. So we can get rid of the minus. What is the domain of the new piece? So what is the domain of this? From 2 to infinity. What's that? Oh, did I draw it backwards? Minus 2, right 2, up 3. Oh, you're right. How did I foul that up? So, right 3, down 2. And then here we're going to go take the square root, right 2. What's that? Oh, sorry. That's a minus. So that's, anyway, that's why it messed up. So this should be, so yeah. All right, that's how I messed up the 2. So my graph's in the wrong place. Should we do another one? Sorry. Let's do a better one. Okay, look at 56. Okay, let's not mess. I'll try not to mess this one up. So, the square root of x squared minus 1. The domain of this, what numbers can you not plug in? Can you plug in 5? 5 squared would be 25, and 25 minus 1 is 24. Can you square root 24? Yes. Could you plug in negative 5? Negative 5 squared would be positive 25 again, minus 1 would be 24. So that works. You can't plug in 0. 0 squared is 0 minus 1 gives you imaginary, so 0's out. What else? So 1, will 1 be okay? 1 squared is 1, and 1 minus 1 is 0, but anything between 0 and 1 won't work. Anything else? Anything from negative 1 to 0 won't work. So the domain of this is from negative infinity to negative 1 inclusive, union with 1, oops, that's a bracket, 1 to infinity. But they have restricted the domain to that, which gets rid of the whole left side, right? So I can get rid of all of this stuff. So now I know the domain. The domain of the inverse is just the range associated with this domain. So let's start looking at it. If I plug in 1, 1 spits out so 1 squared is 1 minus 1 is 0, and the square root of 0 is 0. What if I plug in 2? 2 squared is 4, and 4 minus 1 is 3, and the square root of 3 is like 1.7. All right, what if I plug in 5? The square root of 24, so 5 would give me like 4.9. What if I plugged in 10? Square root of 99, which is like 9.9. Do you see the pattern? When you plug in 11, what are you going to get? You're going to get the square root of 1 less than 11 squared, 10.9. If you plug in 12, what are you going to get? 11.9. So the range would be from 0 to infinity. So the domain of the original is 1 to infinity, and the range of the original is 0 to infinity. Well, if you know that, you just switch these two. So F inverse has that as its domain and this as its range. So if you find the domain and range of the original, then the domain and range of the inverse are just switched. That makes sense? That's probably a better way to explain it. Well, let's do one that has holes or asymptotes. So let's do 52. So the domain of this is going to be all real numbers, but x is not allowed to be -7. Now, is -7 a whole or an asymptote? If 7 plus x cancels, it's a whole. If 7 plus x does not cancel, then it's an asymptote. Can we divide out 7 plus x? Is there a 7 plus x in the numerator? No. So if I had like x minus 5 times 7 plus x over 7 plus x, and those canceled, x is still not allowed to be -7, but in that case, you would have a graph, and then at -7, you would have a whole. But whereas it didn't cancel, you have an asymptote. So at -7, the graph is going to look something like this. Okay? Well, I'll go ahead. We're going to have to review some of this stuff. They didn't do a very good job reviewing it. So, what is the range? Well, are there any numbers that the range cannot be? Is there any way to get this to equal 0? Well, when does a fraction equal 0? When the top equals 0. So does the top ever equal 0? Yeah, at negative 2.5. Okay, and you don't remember this from last year, so we're going to have to review this in a different way. But if the degree of the top matches the degree of the bottom, then the horizontal asymptote occurs when you divide this term by that term. So what is 2x over x? 2. So that is the only number that doesn't happen in the range. And I'll pull out some worksheets to help you remember how to do this, because they just kind of threw it out there without reviewing it. So anyway, the domain of the original is going to be all real numbers. X is not allowed to be negative 7. The range of the original is all real numbers, but y is not allowed to be 2. And then the domain and range for the inverse just switch. So the domain is all real numbers, but x can't be 2, and the range is all real numbers, but y can't be negative 7. Okay? So give it your best shot on this, and then after we finish the last section, I'll make sure that we can review this so that it'll make sense again. Okay? Good luck.